Hi Year 12, I just wanted to quickly go through the multiple choice questions that I set you in lesson today. I was having a very bad morning and did not do a very good job at teaching you, so I just wanted to make sure that you've had a chance to review the questions if you got them wrong, so that you know why and can make corrections next time. So in question 1 you were given this diagram where you've got a resistor that is fixed in series with a variable resistor, a power supply of 6 volts being supplied to both of those, a voltmeter across the fixed resistor, and the variable resistor could vary between 0 ohms and R ohms. So when this is R ohms, the resistance of both is identical. So it asked you to find the initial and final voltmeter readings as the variable resistor is moved from being 0 ohms to R ohms. So when the variable resistor is 0 ohms, it effectively is not a resistor. Okay, so it just provides a pathway of 0 resistance, doesn't take any of the voltage share. In that case, the fixed resistor will take the whole voltage share and will get 6 volts, so the voltmeter will read 6 volts. When the variable resistor is increased to have a value of R, then you've got identical resistances, 2 in series with each other, so they will take a 50-50 split, and therefore half of 6 is 3, and the voltmeter will read 3 volts. So that was quite straightforward. Number 2 is less obvious, so I'm just going to grab some colours to help us do this. So the question was asking what the value of P should be, so what the voltage across this supply should be in order for this ammeter to read 0 amps. Okay, so what we're going to do is we're going to use Kirchhoff's laws to help us out with this. So we know that the current, or the sum of the current entering a junction, must be equal to the sum of the current leaving a junction. And we also know that the sum of the voltage around a loop must equal 0. Okay, those are Kirchhoff's laws that we've learned. We're going to use those. So the first thing is, let's identify the loops that we have. Okay, so let's look at loop 1 is going to be this one here, and loop 2 is going to be this one. Excuse me. Okay, so let's look at what we can already say. So let's look at the voltage across the loops. Oh, we also know that this is 24 volts. Sorry, I forgot to annotate that. Okay, so let's think about adding some current flow direction as well. We've got the positive terminal here, so conventional current is going to flow round. It's going to come in here. So that tells us our direction. Now we also know that the positive terminal of the second power supply is on this side here. Sorry, got my hands in the way here. So the current must flow this way. Now this makes sense because current coming from the top loop is going to meet at this junction, and it's going to combine with this one to form the current through here. Okay, so let's label these up. Actually, that might make life easy. So I'm going to start off by labeling the first value of current I1 here, and I'm going to wait until I get a split. So I've got I1 through the 9 ohm resistor. Okay, I1 plus this incoming one, so the 2 incoming, must equal this one. So let's label this as I2, because I1 plus I2 will make I3. That current there will be the same as the current here, so this is I3. Whatever current is flowing out of this side of this power supply must be flowing into it, so this is also I2. And so we know then that I3 coming down is going to split into I2 and I4. Okay, so that's our currents labelled up. Now we're going to write down things that we know according to the laws. So we're going to start by saying if 24 volts is picked up at this point on the loop, it will then drop a voltage across this resistor, V equals IR, so it must lose I1 multiplied by 9 across this one, and it must also lose 3I3, okay? Current multiplied by resistance here is 3I3. So it gains 24, it loses 9I1 because the current through this one is I1. It loses 3I3 because we've got the current is I3, the resistance is 3. And that's a complete loop. So the sum is 0. Let's look at our second loop now. Okay, so it picks up P, so plus P, as it travels through. The only thing that is dropped here is going to be 3I3, so minus 3I3 must equal 0. Okay. We also know that I2 must equal 0 amps. Okay, the reason we know that is because the question is literally asking what value of P will cause the current through the ammeter to be 0 amps. Okay, now let's have a little look at what else we know. So, I1 plus I2 must equal I3. But we know that I2 is 0, so I can say I1 equals I3. What else do we know? We know that I3 is equal to I4 plus I2. But again, because, sorry, let me just make sure I've explained that. I3 is splitting into I2 and I4. But because we know that I2 needs to be 0, we know then that I3 must equal I4, which must equal I1 from the previous point. Okay, so that's a very helpful thing for us to see. Okay, so I'm going to take what I've just learned here and substitute it into one of my previous equations. If I1 and I3 are equal, which we now know they are from the laws, I can restate equation 1 as 24 minus 9I1 minus 3I1, because I3 is I1, equals 0. Okay, that is the same as saying 24 minus 12I1 equals 0, which is the same as saying 24 equals 12I1, therefore I1 is 24 over 12, okay, which gives me 2 amps. Okay, now this is helpful. I now know that the current I1 is 2 amps, but I also know that I1 is equal to I3 and I4. Okay, so therefore I have 2 amps leaving the battery, I have 2 amps for I4 going into the battery, but I also know that I3 must also equal 2 amps. This is important because let's think about the sum of our second loop. Whatever voltage is picked up across P has to then be dropped across this resistor so that the sum of the loop is 0. Okay, and I now know that I3 is 2 amps and I have the resistance. Okay, so I can say the voltage dropped across the 3 ohm resistor, V equals IR, must equal the current flowing through it, which we've just said is 2 amps, multiplied by the resistance, which is 3. Okay, so 6 volts must have been dropped across my resistor. Now for the sum of the loop to be 0, if 6 has been dropped across this resistor, then 6 has to be gained across P. So therefore P must be 6 volts, and that gives us answer B. Okay, so question 3 has a circuit that has a resistor, a fixed resistor. It has a component X, and it tells us that if light intensity across X increases, then the resistance will decrease across X, and you've got a voltmeter measuring that voltage. So it says, what happens to the current and the voltage if the light intensity on X increases? So we know that if light intensity increases, then resistance drops. Okay. If the resistance of this component gets smaller, the total resistance also gets smaller in the circuit, but it also means that the ratio share of X of the total resistance will also decrease. This is a fixed value. If this gets smaller, then this will take a smaller share of the total resistance. Okay, if it takes a smaller share, then the voltmeter reading will decrease. Okay, if the resistance of X has gone down, then total resistance has also gone down, sorry, not gone up, that's also gone down. Okay, this is fixed, this has got smaller. Total resistance has decreased. Current flowing through the circuit is the voltage supplied over the total resistance. Well, we haven't changed the voltage supply, so this V is the same. The total resistance has got smaller, and so therefore we can say that current increases. Okay, last but not least then, you have a circuit that has a variable resistor varying between 0 and 9 ohms, and you have a 3 ohm resistor that has a V out across there. So we're measuring the output voltage across the 3 ohm resistor. And it says, what is the difference between the minimum and maximum V values across the 3 ohm resistor? So the minimum voltage across the 3 ohm resistor is going to occur when the variable resistor takes the biggest possible voltage share, okay, because the 12 volts is going to be split between the two. The amount will depend on the value of this. When this is maximum, this thing takes the biggest share possible of the 12 volts. Okay, so the minimum voltage across here is going to be a 3 out of a total of 9 plus 3, sorry, that's 12, share of the 12 volts. Okay, so clearly you can see that that's 3 over 12 multiplied by 12 gives me 3 volts. So at a minimum, I will have 3 volts across here. The maximum voltage across the 3 ohm resistor is going to be when this variable resistor doesn't take any of the voltage share. So when it has 0 resistance, it won't take any of the voltage share. So in that case, it will then mean that this 3 ohm resistor is able to take all of the voltage possible because the variable resistor isn't taking any. Okay, and therefore the maximum is 12, and that gives us answer C. Sorry, I should also clarify, it's asking for the difference between the minimum and the maximum, and obviously 12 minus 3 gives us 9, that's why it's C.